All right, maybe I'll just do this as a demonstration. So let's say that you go get on the Ferris wheel at Navy Pier, okay? And we're just going to use you and a friend. So the Ferris wheel somehow is magically massless. Any guesses as to how tall this is, by the way?
Which one?
The one at Navy Pier.
135 feet.
That's a dang good guess. It's 150 feet. So let's say that you and a friend and the basket that you get into are 200 kilograms, okay? And when the Ferris wheel starts up, it produces a torque of, I don't know, let's say 1,200 Newton meters, okay? And I want to know if the Ferris wheel produces that much torque, what's the angular acceleration? Now the equation is torque equals I alpha. Rotational force, moment of inertia, and angular acceleration. So the 1,200 goes here, Newton meters. I will have to figure out, and alpha is what we're solving for, right? That's what we want. So what would the moment of inertia be of we're just going to say this is the torque on just the people, so we're not going to worry about the Ferris wheel itself. Moment of inertia is xmr squared. So if they are a point mass on the outer edge, if you recall all these shapes, right? And by the way, if you think about this point mass, if it's spinning really fast like the stopper that we did in the lab, and you blur your eyes, what shape does that point mass take? A circle, like a hoop, right? Like a hula hoop. Notice. Same I value. The x is what here? 1. What's the x value here? 1. What's the x value here if they're considered a point mass? 1. Okay. So to solve for moment of inertia, you got 1. The mass is 200, right? And what's the radius?
75.
75 feet. Hello, what do you got to do? Oh, whoops, other way. 3.3 feet in 1 meter. Can somebody do that math for me real quick? Quick like. $22.7. So this whole value goes here, and then solve for alpha and tell me what you get. The calculator's flying here. Josh, what'd you get?
0.116. 0.0116.
That's not what I got. Wait, babe, hold on. Maybe I changed something. Yep, I got that. 0.0116. So 1.16 times 10 to the negative 2. What are the units for alpha? Yeah, radians per second squared. Good. Hard to know whether or not that's big or small because we don't live in that world, right? That's spinning things. So what would we do to convert it to linear acceleration? Look at the board. Convert from angular to linear. What would you use? So try that. You know what alpha is. You know the radius. That's the radius, 22.7. Tell me what the linear acceleration would be. I heard it somewhere. Sahana, what'd you get? Yep, that's right. 0.26 meters per second squared, which again doesn't seem like that big of a deal, right? So let's say we do this for, I don't know, 5 minutes. What's the final speed? If you did that, if you accelerated for 5 minutes. So we're going to start from rest when we climb onto the Ferris wheel. Anybody have an answer they'd like to venture? Eric, did you get this one yet? No. Not yet? Neither, Eric? All right.
78.
78 is what I got as well. So the final velocity is 78 meters per second. That's kind of fast. Convert it to miles per hour. First one to get miles per hour gets an extra credit point. Some of you are like, I know. Can't do that fast.
Is it 53?
No. Nope.
Meters in a mile.
Miles per hour. There's 5,280 feet.
16.2.
No.
135.5.
That's close enough for me. That is close enough, yeah. Yeah, I used a quick conversion. About 175 miles an hour. So, not realistic. We are not going to accelerate in that Ferris wheel for 5 minutes. That's the point. Yes, Patrick, you get the extra credit point. All right. Tonight's homework is 8C, I believe, 7 and 11. 7, 11. And it is online. I've already put it online for you.